And welcome back to round two, my party people. Today, right now, we're going to get straight into it. We're going to get straight into the practice, starting with problem number one. And your job is to give it your best shot. And today's theme is going to be always ask why. Whether you get it right or get it wrong, I know it's exciting to get a question right, but during practice, as always, we must ask why so that way we have the best chance of repeating that success and avoiding those repeated mistakes on the test. So with that said, let's go ahead and dive on in here. Let me move here to our practice screen. You are going to receive 2.5 minutes per question, 2 minutes and 30 seconds per question. So if you are watching this as a recording, when you see the problem, simply pause the video, time yourself for 2.5 minutes, and then press play once you're ready. But without further ado, my party people, let's go ahead and get started. So here we are with our first question, my party people. And as always, the first thing we always want to do is read the question sentence. Remember that the information is just going to be jargon until you actually understand what the goal is. So here we are. We look at the question sentence first, and it says, how many yards long is the running course? My party people, can we confirm that we're looking for the length of the running course, but specifically, we're looking for it in yards? Can we confirm that real quick before we get started? Sweet, sounds good. Again, two things. One is what we want, and the other is the specification of what we want. The length of the running course, but specifically in yards. Now let's see what we have going on, so that way we can try to make a plan to get to the running course in yards. A school track team needs to set up a practice running course. The coach measures the course and finds it to be 216 feet long. Again, the running course, he measures the course 216 feet long. My party people, this is our answer right there. That's the length. However, we don't have it in what unit? We don't have it in what unit? What unit do we need again? Yeah, we need yards. So we have 216 feet. And the overall goal here is to turn this into the number of yards. So let's play off of the basic strategy that we learned, not the more complex one, the conversion rate. Let's go ahead and talk about the basic strategy, small to big, big to small. Everybody, we're starting from feet and we're trying to end up on yards. Is feet the big unit or the small unit in this case? Yeah, in this case, this is the small unit. Feet, when you compare it to a yard, well, a foot is smaller than a yard. Remember, everybody, here's the actual conversion. It is 1 yard equals 3 feet. So if you take a foot like so, and let me go ahead and make a better rectangle without the use of technology. So if this is, let's say, 1 foot, well, 3 of these is what makes up a yard. 1 yard is 3 feet. And so just to basically verify here, again, the foot is going to be the small unit. The yards is going to be the big unit. And so with that said, everybody, when we're going from a small unit to a big unit, remember, we're trying to group up the small units as many ways as we can. And when you're grouping things up, what operation is that? When you're trying to see how many groups you can make. Yeah, when you're trying to see how many groups you can make, that is division. How many groups of yards can we make? That is division. And so just to remind myself, just to help me out, everybody, what number are we actually going to be dividing by? Correct. Always pay attention to that conversion. We are going to divide, and it's going to be specifically by the conversion number, which is going to be 3. And so that's it. There's our process. We're good to go. Now let's go ahead and calculate, and we'll be good. So let's zoom on in a little bit, and let's do 216 divided by 3, which also shows as this 3 going into 216. And let's get the job done. 3 doesn't go into 2, but 3 does go into 21. 3 goes into 21, correct, 7 times. And once we do that, 3 times 7 is 21, giving us a remainder of 0. We'll drop that 6, and this is the easy part. 3 goes into 6 exactly twice. Exactly, there we go. So we subtract the 6. We have a clean division, no remainder. And so the final answer is we were able to make 72 groups or 72 yards. And there we are, my party people. There is our first answer right there. The correct answer here is B, 72 yards. So, how was that warm up for us, everybody? How are we feeling so far? Do we feel like we're picking up right where we left off in the previous lesson? Or if we're still kind of, lagging behind a little bit? All right, okay, looks like we're feeling pretty good. For the most part, good little warm up, okay. Now, let's keep it moving forward here. Let's go into practice problem number 2. And again, we always want to ask why. So when we look at this question real quick, and I'll keep this on the recording. So the basic strategy rule is if you compare the units and you need to convert, if you're going from a big unit to a small unit, you are going to multiply because you're breaking up that big unit into a bunch of smaller units. So again, we are multiplying when we are going from a big to a small unit. When we are going from a small unit to a big unit, we are going to divide. And that's because we are grouping up the small units as many ways as we can to turn it into the bigger unit. And so that's why we would divide. So again, all in all, just have this written down at the top of your paper. Big unit to small unit, multiply, small unit to big unit, we will divide. Go ahead and type got it in the chat box before we move forward to make sure that you have this written down. All right, so on to the next problem here. First things first, as always, I don't care if the problem is one sentence or 50, we always begin with the question sentence. And so here it says, how long will each piece be? Okay, so how long will each piece be? Now, my party people, when we look at the answer choices, what do we notice? Do we notice that we have 1 unit or 2 units in this here? Yeah, we have 2 units. We have feet, and some of these choices have inches in them. So what that means to me is that from whatever we start with, whatever operation we do, whatever happens, at the end, it's possible that if we have a partial number of feet, like let's say 1.5 feet, well, we need to convert that decimal to inches. It's not accepting a decimal answer. It's going to be feet and inches if there is a leftover number of inches. So with that said, let's go ahead and understand what's going on here. It says that a pipe that is 6 feet long needs to be cut into 4 equal pieces. So when we think about that, let's say we have this pipe. Okay, there it is. And this pipe is 6 feet long. Everyone, when we read this right here, cut into 4 equal pieces, what operation does that scream to you? Yeah, that's going to be screaming division. That's division all day. When we are cutting into equal pieces, yeah, that's going to be division. And another little hint is the word each, because how long will each piece be? It's basically insinuating that we're starting with the whole thing, and we are going to be either multiplying or dividing with the word each. But because we're looking for each, we're going from the total down to the piece, which is, again, division. So there are 2 ways that we can get this problem done, everybody. 2 ways. I'm going to show you option number 1, and then I'll show you option number 2 over here. So option number 1, I'm going to take the 6 feet, and I'm going to convert this into just inches. Then I'll divide by 4, and then write it as feet and inches if there are any leftover number of inches. And I'm going to tell you right now, I already know that we are going to have feet and inches. How do I know this? Everybody, quick question. 6 feet, is it divisible by 4? Like a clean 4? No, it's not. It's not a clean division. So we know at the very least that this is not going to be a whole number of feet. It's going to be some number of feet along with inches. So just based off of that, everybody, if you make that quick observation, which answer choices can we eliminate immediately? Yeah, we can eliminate A and D. A and D can go bye-bye immediately because we know that 6 feet divided by 4 is going to contain a decimal. It's going to contain a partial value, and A and D are not partial at all. So boom, get out of there right now. Now let's go ahead and convert here turn it into inches, and then divide. Everyone, if we are going from feet to inches, are we going from small to big or big to small? Which way are we going here? Yeah, in this case, we're going big to small. And again, the question you want to ask yourself is a foot smaller or bigger than an inch? And a foot is very much so bigger than an inch. So I can confidently say that we are going from a big unit to a small unit. And when we go big to small, the operation that we'll use is multiplication. And multiplying by what number again? How many inches are in a foot? Yeah, 12. So everybody, quick question. What is 6 multiplied by 12 going to be? Yeah, that's an easy 72. So 6 feet is 72 inches. Once we get to this point, again, all we just did was converted the feet that we had into inches. Now, what do we need to do, everybody? We have to divide that amount by 4. That way we can get the size of each individual piece. So let's do that. Let's go ahead and try to do 4 going into 72. 4 goes into 7 just once. And we'll subtract the 4 right there, giving us 3 left over. Then we'll continue by dropping that 2. And we'll ask ourselves, how many times does 4 go into 32? And that'll be 8 times right there. Right on, everybody. So now that we have this, we know that the cut for each piece is 18 inches. Great. We have that right there. So equals 18 inches. But we need to turn this into not just inches, but feet and inches together. So everybody, one more time, pop quiz. How many inches are in 1 foot? Yeah, 12 inches in 1 foot. So if I take away 12 inches from the 18, that's going to be 1 foot, because this is, again, 12 inches is 1 foot, and then we have a remaining 6 inches. Another way that you can think about it is when you do the division to convert, you can divide 18 by 12, and you'll see that 12 goes into 18 one time, so that's 1 whole foot. And when we subtract the 12, we get 6 remaining inches. And there we go. That's one way to do this problem. But who here agrees that this is a little lengthy? That took a little while. Who here agrees with that? Yeah, and I agree. I would agree with you if you said that. Yeah, that was definitely a slightly lengthy way of doing it. Now, let me go ahead and explore something curious here. Let's suppose that I just go ahead and say, let's just divide the 6 feet by 4. Let's just go ahead and divide it by 4. A pipe that's 6 feet long, 4 equal pieces. Let's just divide. Let me go ahead and just do that here. So 6 divided by 4, 6 feet divided by 4. Let's go ahead and do it. And I know it's going to be a decimal, so I'm going to include just 2 of these just in case. So 4 goes into 6 exactly 1 time. We subtract the 4 to get 2 left over. I'll place the decimal in the same exact location where it was so we can keep being consistent. So from here, we'll drop the 0. And so 4 goes into 20. How many times, my party people? Yeah, that'll be 5. And so with that, 5 times 4 is 20. So that is a clean division. So we get 1.5 feet. So that is the size of each individual cut. 1.5 feet. Now, quick question, everybody. Because we know that the answer needs to be in feet and inches, what we're really going to focus on is that partial number of feet, the 0.5 that we see right there. Can anybody tell me what 0.5 is known as? You know, if we think about, let's go ahead and say 0.25, that's a quarter. So what's 0.5 going to be? Yeah, that's half. 0.5 is literally half of what you're talking about. So quick question, everybody. Again, that's half. Can anybody tell me what half of a foot is in terms of inches? What's half of a foot? Yeah, 6 inches. So there's our answer. 1 foot, 6 inches, and we can be done much faster. Now, what's the difference? The difference between these two methods is that if you are comfortable with decimals, you have the advantage of saving time. If you are not comfortable with decimals at all, and you're the kind of person that will avoid decimals no matter what, at all costs, you're going to catch yourself taking more time consistently to do the same work. My party people, before we go on to the next problem, does that make sense to you personally? Sweet, right on. All right, let's go ahead and move forward here to the next one. As always, let's keep giving it our best shot. You got this. All right, next question here, my party people. Let's go ahead and begin by addressing the question sentence. Again, the information doesn't matter until the story makes sense. And this story is going to begin with the end. What do we want in the end? How long will each piece be? So we see that we have a similar premise to the previous question, a pretty similar premise. So let's verify that we're doing the same thing. So here's what we're talking about. We have a long rope, 11 feet and 3 inches long. It needs to be cut into 15 equal pieces. Whew, okay. In the previous question that we did, we were using a much smaller number, 4, in fact. So was anybody here intimidated by seeing this large number of feet and inches and then dividing by a large number? Was anybody here intimidated by that? Yeah, more yeses than nos. I'm glad it's not all yeses, but a lot of yeses versus nos, and that's pretty reasonable for where we're at. I understand. But we have to really bear that responsibility of improving in this regard. So don't forget, everybody, although it may not be your fault that you're not confident with numbers, it is absolutely your responsibility to get there. So let's go ahead and get this going. We want to know essentially what 11 feet and 3 inches divided by 15 is. That's what we need to do. So with that, well, everybody, are these going to be clean divisions? 11 feet divided by 15, 3 inches divided by 15. Is this going to be clean at all? Absolutely not. So talk to me. What is that C word I'm thinking of in terms of the next step? Giovanni, that's correct. We're going to convert the feet into inches. Exactly, Giovanni. So with that, let's go ahead and do that. Let's take this and convert, and let's bring this down here. So I'm going to take a little detour and take the 11 feet, 3 inches. And just remember, we can leave this the same. We can leave the 3 inches the same. We're going to work with the 11 feet. Everybody, to convert feet into inches, what are we going to do? Multiply or divide, and by what number? That's right. We are going to multiply and by 12. Just as a reminder, 1 foot is equal to 12 inches. So remember, because we are going from a big to a small, a foot is bigger than an inch. So because we're going from big to a small, we will multiply by 12, and this should be pretty straightforward. Because, everybody, 11 multiplied by 12 is what? 132. That's right. We got to know those multiplication tables. So there we are, 132. Booyah right there. And now we're just going to go ahead and forget everything else exists. Just go ahead and throw the 132 inches. What did we do wrong, everybody? Yeah, we got too excited. Remember, it was 11 feet and 3 inches. So don't forget to bring that back into play. So let's duplicate that, bring that back, and it should actually be 135 inches. And there we are. Now we're set to get this done. We have 135 divided by 15. So with that said, that's 135 inches, just to be very clear. And there are 2 real ways that we can go about this. 2 different ways. But the first is going to be that long division way, and you're going to see that we're going to end up guessing and checking regardless. Let me go ahead and get that going. So let's zoom on in, and let me just show you. When we divide the 135 inches by 15, here's the problem with that. We see that 15 doesn't go into 1, 15 doesn't go into 13, 15 doesn't go into... Oh, well, now we have to figure that out. We have to guess at what that is. So when we guess and check, let's go ahead and suppose that we start off with, let's say, 8, just to get kind of close. If we do 8, we have 5 times 8, which is 40. Carry the 4. 1 times 8 is 8. Carry the 4 is 12. So we're at 120. We're close, but we're not there yet. If we add on another 15, or if we do 15 times 9, we'll get there. It'll be 135, because 120, adding another 15, that's going to be 135. That's going to be 15 times 9. So the answer here is going to be 9, and we're good to go. So the answer here is going to be 9 inches. But before I review the problem start to finish again, I want to go ahead and just show you that if you are in this situation where you are forced to guesstimate and see what it's going to be, one thing that you can do is break down the division into two easier divisions. This is a nice little trick I like to use, especially when it comes to division by big numbers. Everybody, quick question. In terms of multiplication, what two numbers make up 15? In terms of multiplication, what two numbers make up 15? Yeah, 3 and 5. 3 times 5 is 15. So let me show you how I'm going to play this. Let me just make this a little smaller. Let me place that over there. So 15 is the same as, again, 3 times 5. Watch what I'm going to do here. I'm going to give myself an easier time by doing step A. I'm going to divide 3 into 135. Watch what happens. 3 goes into 1. It doesn't. 3 goes into 13 4 times. 4 times 3 is 12. 1 left over. Drop the 5. 3 goes into 15 5 times. So we have 45 and a clean division. All right, everybody. So help me out. We divided by the 3 and we ended up getting 45. What number do we have left to divide by? The 5. Okay, great. Everybody, what's 45 divided by 5? What's that going to be? Boom, 9. There you go. All done. So here's a little trick. If in case you didn't know this is a very good fact to know. If you are dividing by a large number and you know it's going to be a little troublesome, you can actually just divide by its factors. Just make sure that the factors you use will multiply to that number you're dividing by. So 15 is the same as 3 times 5. So that gives you permission to divide by 3, then divide that result by 5, and you'll get your answer. You can also go the other way. If you wanted to divide by 5 first, 135 divided by 5, that's going to be 27. And then 27 divided by 3, that'll give you 9. So either way, you'll still get the correct answer, using a nice little trick to help you out. Long live Coach Anderson. Oh man, of all the things I'd never expected to see in classes, that's a funny one. But I'm glad that you appreciate that, seriously. But let me go ahead and just go through the problem start to finish real quick, and then we'll continue going with more practice. So with that, here we are. Remember that when they asked us to cut this rope into 15 equal pieces, that's what we needed to do here. We needed to divide by 15. And then with that said, to divide by the 15, we saw that we had to convert this first. To convert feet into inches, remember that's going to be multiplication of 12. There are 12 inches in every foot. So for every foot that we have, we multiply by 12, and that got us 132. The reason I ended up writing 135 is because we have to tag along the 3 inches that we had in the beginning. It was not just 11 feet, but 11 feet and 3 inches. So that's why when we got the 132, we added the 3 inches to it to make it 135 inches, because that is the true length of the rope. So now that we have the length of the rope, we divided it by 15, and whatever your preferred method is, long division, using some tricks with mental math, whatever way it is, you're good. But just know that in the end, we had to divide that value by 15. We got 9 inches, and we are done. My party people, are we good to continue on to the next question and continue kicking some butt? So taking a look at this next practice problem, let's go through the routine here. First things first, let's interpret the goal. So if the item is 3 feet, 8 inches long, this means nothing to me right now. So if the item is this length, again, don't read the whole thing. Don't care about the whole thing. It's if the item is this long, what is the final price? Great. Sounds good. That's what I care about. All I want to know about this decimal and unit conversion ridden problem is the final price. So final price is what I'm going to write down, blank. So with that said, let's now read the story to understand what's going on. That sentence that I read at the end, that's what I'm going to write down first. The item here is 3 feet, 8 inches long. So item equals 3 feet, 8 inches long. Okay, cool. So now, up next, I'm going to ask myself, well, what other pieces of information do I have? And what I see is that it says an item is sold at a price of 23 cents per inch. Everybody help me out. Let's go ahead and read that very carefully. 23 cents per what? Inch. Per inch, everybody. So think about real world situations. This is something that I always like to do. Just comparative thinking. If I'm, using easier numbers and I'm saying like, hey, if I'm buying something at $10 a pound, I'm going to multiply by pounds. If it's $5 per inch, I'm going to multiply by the number of inches. So in this case, my party people, in this case, given that the price is 23 cents per inch, we need to multiply by the number of what? I need to hear you write it. Need to hear you say it. If it's 23 cents per inch, we need to multiply, that's right, Dom, by the number of inches. Use that reasoning. Again, ask why. And it's because it's per inch, not per foot and inches, but per inch. So given what we have, everybody, the 3 feet, 8 inches, what do you believe we need to do with that before we are able to multiply? Yeah, we got to convert it. We just have to convert it and we'll be good. So let's figure out the number of inches that this represents. So help me out, everybody. What do I multiply feet by to get inches? 12, exactly, because we're going from a big to a small in inches. So 3 times 12, that's going to be 36. We still have the 8 inches from before. What is 36 plus 8 going to be, my friends? Yeah, that's going to be 44. And there we are. 44 inches is what we're dealing with. So I'm going to write that down right there. And we're good to go. We have 23 cents multiplied by 44. And now we can multiply. Now we're good to go. Now you just need to remember your rules for engaging and multiplying with decimals. So let's write this down. 44 multiplied by 0.23. I'll just write 0.23. It's the same exact thing. And here we go. First rule with multiplying by decimals is ignore the decimal. Multiply like normal, and then we'll bring that decimal back at the end. 4 times 3, that's going to be 12, and we'll carry the 1. Then 4 times 3, that'll be 12, carry the 1, and we have 13. So boom, all done with step 1. Now step 2, we're going to be dealing with the 2, so we have to start right here. So I'll place a 0 on the other place value. Now we'll continue on. 4 times 2, that'll be 8. 4 times 2, that'll be 8. Add this together, and now we have 2, 11, carry the 1. 1 plus 1 plus 8 is 10. So we did the first part correct. We ignored the decimal and we multiply like normal. At the end, we'll bring the decimals back. Up here for the 44, we have no decimal, so nothing to bring there. But for the 23, we have 2 decimal places that we're going to bring back right here. 2 seconds. 1 and 2. And so the decimal goes right there. And our final answer will be a price of $10.12. And there we are. The correct answer to this one is A. The majority of us here were correct. So great job, everybody. I'm glad that your confidence was backed up with reasoning. And that's how it should be. So with that, as always, let's prepare for the next one. And remember, start with the question sentence, write down your information, build that connection, and only then are you supposed to actually calculate. Don't calculate if you don't know that you're going on the right path. All right, here we go, my party people. And let's tackle the next one. So when we take a look at this one, everybody, let's look at the end goal. What is the running time for each lap in minutes and seconds? Okay, so here's what we want. We want 1 lap, and that's going to be ultimately in minutes and seconds. And if you look at your answer choices, yeah, for sure, you have minutes and seconds all the way here. So let's go ahead and get into it here. We see that a runner completes a race in 12 minutes and 36 seconds. So let's highlight that there. Completes in 12 minutes and 36 seconds. So that's the total time. All right, sounds good. Then we see that it says it's divided into 4 equal laps. Okay, What is the running time for each lap in minutes and seconds? All right, so we see clearly here that it says divided into 4 equal laps. So my party people, is it true that one of the ways to do this, given how we've been tackling problems so far in today's class, is it true that one of the ways to do this is to take the 12 minutes and 36 seconds, convert it into seconds, then divide by 4, and then turn whatever you get back into minutes and seconds? Is that one of the ways to get this done? Hey, I'm not asking you to judge it. I'm not asking you to judge me. I'm asking you if it is one of the ways to get it done. Yeah, for sure, right? It is one of the ways to get it done. But overall, everybody, don't lose sight of the overall purpose. Everybody, what is the overall thing that we're doing? We're taking the amount of time that we're given, and we are simply going to divide it by what? Yeah, we're simply going to divide it by 4. That's it. That's the goal here. We are here to take the total time and divide it by 4. When you choose to convert, ultimately is up to you. You are supposed to convert if it is beneficial to you. In this case, everybody, you don't have to convert. This is honestly a 10, 20-second problem, and you're good because of the convenience of the numbers that you have. Take a look at the convenience here. If I were to choose to just say, hey, the goal here is to divide this by the 4 laps, so we see the time per lap. Everybody, quick question. When it comes to dividing by 4, what do you notice about 12 and 36? Yeah, Ariane, they are clearly divisible by 4. So in this particular case, everybody, although we can convert this into seconds, then divide by 4, then turn it back into minutes and seconds, do we have to do that here? Correct. We do not. We do not have to do that. And so this is one of those examples that I'm proud to show you because it's very easy to overthink some things. It's very easy to only choose to do the only way you know how to do something, and that clouds your judgment. In this particular problem, if you would have noticed that they're clearly both divisible by 4, then guess what? Your answer is going to be, hey, 12 divided by 4, that's 3. We'll keep the minutes on that. And then if we take a look at this, 36 divided by 4 is 9, and we keep the seconds on that. And there we go. There's our final answer. 3 minutes and 9 seconds, because 12 minutes and 36 seconds is divisible by 4. Both of those values are clearly divisible by 4, and that could have saved you a ton of time that you can use on the next question. So my party people, let me know, did you get got? Or did you see that all the way through? So moving on to this next question, my party people, we see that we are looking to find the length of this fabric roll, but in what specific unit? Answer me that. What specific unit are we trying to find this answer in? Yeah, it's in inches. Notice that the problem clearly states how many inches is the fabric roll, and all of the answer choices all say inches. Cool, sounds good. So it's very clear there that our final answer needs to be in inches. Sounds good. But what do we have to begin with? Well, this fabric roll that we're given, it's given to us as 3 yards and 2 feet long. Okay, so let's understand what's going on here. We have 3 yards and 2 feet. Very interesting. However, this should be no major problem at all. We should be able to work through this because really the general goal is to take this and eventually turn it into just inches. But there's a little bit of a unique situation here because it's not going to be directly from feet to inches. We have yards as well. So we just have to be a little careful, but it's still very doable because the first step, in my opinion, is going to be taking this and turning it into feet. And then once we have it as feet, then we'll convert it into inches. So it's a little 2-step process here. And if you're calm, cool, and collected, you'll be able to see that this is absolutely possible in the 2.5 minutes that we had. So let's go ahead and get into it. We already have 2 feet right here. So it sounds like the goal is going to be taking the 3 yards and turning that into feet. So with that said, who knows the conversion? How many feet equals how many yards? Someone give me that in the chat box, please. That's right, 3 feet in 1 yard. Perfect. So let's write that down here on the side in purple. Let's go 1 yard equals 3 feet. And so with that said, everybody, what this means is if we're going from yards to feet, we are going from a big unit to a small unit. It takes 3 feet to make up 1 yard. The yard is the bigger unit in this case. So big to small, we are going to multiply. And then once we're at feet and we're going to inches, same deal. We're going to multiply again. But let's go ahead and go through one step at a time. Everybody, 3 yards, we are going to multiply by 3 because, again, 3 feet in 1 yard, and that's going to give us 9 feet. So again, 3 yards is 9 feet. But what are we forgetting before we continue so we don't make this mistake? Yeah, we're forgetting the 2 extra feet that we had before. So let's go ahead and make sure that we take that into account. 9 feet plus 2 feet, that's going to be 11 feet. Now that we're here at the 11 feet, again, the end goal is to get this in inches. So now we need to convert feet to inches by multiplying by 12. Every foot equals 12 inches. Big to small, we multiply. So everybody, 11 times 12, what's that going to give us? Knowing our multiplication tables, correct, 132 inches. And there we are. The correct answer here will be answer choice C. Booyah. So again, this problem is more difficult by the conversion steps. It wasn't just one singular conversion. It was multiple steps going from yards down to feet, down to inches. And so to explain here, we converted yards to feet by multiplying by 3. Remember that every yard is 3 feet. Since we have 3 of these yards, times 3 for every yard, that's going to be 9. So again, we multiplied by 3 at first with the yards to go to feet because every yard is 3 feet. Then to go from the 11 feet that we had in total, because 9 plus 2, that's going to give us 11. And to go from feet to inches, remember that every foot is 12 inches. And so since foot is bigger than an inch, we are multiplying, breaking up every foot into 12 individual inches. And that's why we multiplied by 12 at the end to get 132. And there we are. And if you did this in your head in a much faster way, knowing that every yard is going to be 36 inches, you can just do 36 times 3. Sure, that would absolutely work. That would end up giving you 108. And then 2 feet, that's going to be 24 inches. So then you would have 108 plus 24, giving you 132. If you did that in your head, kudos to you. You are absolutely way ahead of where we are right now in terms of the calculation step. Great job on you. So with that, let's go ahead, prepare ourselves for the next question. Let's keep it going. We should be able to get through all of these prepared questions today. Maybe. We maybe will, because I have a couple of curveballs here and there, but let's see how you do. All right, here we go with the next practice problem, everybody. So the first thing we always want to do, and I know I sound like a broken record, is we are going to read the question first, the question sentence. So reading that question sentence, it says, if the carpenter needs to make 4 identical shelves, that's not what matters. It's this. How many feet of wood will they need in total? Okay, sounds good. How many feet of wood would we need in total? Okay, blank feet of wood in total. Sounds good, my party people. Is that correct for you? Before I begin, we are looking for the number of feet of wood in total. Cool. Sounds good. Now, before I continue, because clearly, a lot of us are split between B and C, so I want to go ahead and kind of address this now. Who here felt like they were just automatically going through the same motions that they've learned in today's session? Who here feels like that was you? Okay, quite a few of us. And again, no shame in that. I'm just asking the question so I can help you discover where it is that potentially you might have gotten wrong. Because remember, everybody, if you are going based off of just pure hunches and not reasoning, not evidence-based reasoning, then you're going to have a hard time when it comes to learning from those mistakes or even spotting mistakes before they actually materialize and you get a question wrong. Let me show you what I mean here. Everybody, what is the one thing that I say that matters more than the numbers? What is the one thing that I've said from the beginning of time that I started teaching? What have I said is more important than the numbers? It starts with an S. S, T. I see some of you guys are getting around it, like setting it up, the Y, the understanding, but it's STORY. The story. The story matters more than the numbers because the story, that's what brings the numbers together. Let me show you what I mean here. So, in this question sentence, we know that we're trying to find out how many feet of wood that we'll need in total. But let me highlight this part of the sentence where it says, if the carpenter needs to make 4 identical shelves. Okay, we need to make 4 identical shelves. So basically, we need to find the total feet of wood for 4 shelves. Everybody, are we looking for one individual shelf or are we looking for 4 shelves together? Which one is it? Which one is it? Yeah, we're looking for the 4 shelves together. This problem on the surface looks like it's very similar to those previous questions where we had to divide. Very similar. I will level with you. But when you read the story, it says the carpenter needs to make 4 shelves. How many feet of wood will you need in total? So we need the amount of wood for 4 shelves, not each individual. If we were looking for each individual, yes, we would be dividing. But that's not the case here. We have right here, let me highlight this in blue. The blueprint shows that each shelf needs to be 30 inches long. Quick question, everybody. What's another word for the word each? What's another word for the word each? If I say each shelf is 30 inches long, that's right. A single shelf is 30 inches long. The word per works there too. 30 inches per shelf. That works as well. But can you level with me? Can you agree with me here that reading the phrase, each shelf needs to be 30 inches long, that means that one shelf equals 30 inches. Is that agreeable to you? All right. So with that, I can see some of us in the chat box starting to, grab that cardboard cutout, getting ready to get the pitchforks out. I get it. But everybody, follow along with me. If one shelf is 30 inches, what do we need to do to the 30 to scale up to 4 shelves? What do we need to do to that 30 to scale up to 4 shelves? That's right, multiply by 4. We're going to multiply by 4. Everybody, 30 multiplied by 4 gives us what? 120 inches. That is going to be the amount of wood you need for the 4 shelves. I don't even need to write that again. I clearly see it right here. 4 shelves is 120 inches. However, everybody, the final answer isn't supposed to be in inches. It's supposed to be in what? In feet. That's right. So what do I do with inches to turn it into feet? 120 inches. What do I do with that? Yeah, we're going to convert by dividing by 12. That's correct. Because if we are going from inches to feet, 1 inch is small compared to 1 foot. So that's what we have. We have small going to big, which means we will divide. And so with that said, we'll divide by 12. 120 divided by 12 is a total of 10 feet. And that makes the correct answer here, C. Boom. So my party people, even if you made a mistake, remember, the experience is in learning why. So for those of us that made a mistake, do we understand what that mistake was and what we should have done instead? And there we go. That's growth. That's growth. Even if we got it wrong, remember that we want to get it wrong in practice so we can learn from the mistake so we don't make that mistake on the real test. I got y'all. So let's go ahead and continue the party here. Step by step, problem by problem. Y'all got this. Keep up the great work. And let's keep it going here, everybody. Let's keep raising those scores. So the first thing that we want to really observe here in this problem is, again, the question sentence. How long was the pipe before being cut? Okay, sounds good. So how long was it before being cut? Everybody, quick question. when we are talking about, hey, what was this or how long was this before we took an action, before we cut it, does it sound like we're working forward or working backwards here? Does it sound like we're working forward or backwards in this case? Yeah, it really sounds like we're working backwards. Again, how long was the pipe before being cut? So I'm going to take that, I'm going to really notice that, and then move forward to write down my information. But I'm going to refer to this and see what meaning this has, what effect this will have on my problem solving process. So a pipe was cut into 3 equal pieces, each measuring 1 foot and 6 inches in length. Okay, cool. So let me kind of draw this out here. We had this pipe originally, and this pipe was then cut into 3 equal pieces. And then we get the result, which is going to be 3 pipes, 3 pieces there. Shouldn't have done that right there. So we have 3 individual pieces. And everybody, each of these individual pieces was how long? Yeah, 1 foot, 6 inches each one. So this one was 1 foot, 6 inches. So was this one. And so was this one. So everybody, think about how the story went. We started with the original pipe. We cut it into 3 equal pieces, which is division. And we got 1 foot, 6 inches for each of those individual pieces. Everybody, if we're working backwards to get the pipe before it was cut, what is the opposite of dividing by 3? What is the opposite of dividing by 3? Correct. Multiplying by 3. That's how we'll get the original length of the pipe. So let me zoom in here on the right side. And so I'm going to take the 1 foot, 6 inches, and I'm going to multiply it by 3. That's what I'll do. This is going to be able to work because everybody help me out. First things first, 1 foot multiplied by 3, that's going to be 3 feet. 6 inches multiplied by 3, that's going to be 18 inches. So everyone, is this a proper way to write down a length in feet and inches? Absolutely not a proper way at all. But it's just a quick one last additional step and we're good to go. Because we have to remind ourselves that 12 inches is the same as 1 foot and we had 6 inches left over. We'll bring this together with the 3 feet and that's going to give us 4 total feet with 6 inches as the partial. And there we go. The correct answer here will be D, 4 feet and 6 inches long. That was the length of the pipe before it got cut. So with that, everybody, how are we feeling? Or are you ready for the next one? Yeah, and no worries if you're feeling a little lost. Let me just do a brief explanation again. So think about how the story is presented here, everybody. It says that the pipe was cut into 3 equal pieces, and each of those pieces was 1 foot, 6 inches. So think about how that said. After we divided by 3, we ended up getting 1 foot and 6 inches. So if we're going to work backwards to see how long the pipe was before it got cut, we need to work backwards. We need to do the opposite. We got here by dividing by 3. To get back to the original, we have to multiply by 3. And so 1 foot, 6 inches, when we multiply that by 3, we end up getting 4 feet and 6 inches in length. Now, even if this part didn't make sense here, I will go ahead and actually, before I continue, I'll calculate the 1 foot, 6 inches as just inches, multiply by 3, and then I'll bring it back at the end in terms of feet and inches. So let me go ahead and do that for us here. Let me just show you what that looks like. 1 foot, 6 inches. Everybody, quick question. 1 foot is how many inches? Correct. That's going to be 12 inches. So we end up having 12 inches with 6 inches, which is going to be 18 inches. So again, 1 foot and 6 inches is the same as 18 inches. 12 inches in a foot plus the 6 that's there gives me 18. Now I'm going to move forward by multiplying that 18 by 3. 18 times 3, 8 times 3 is going to be 24. carry the 2. 1 times 3, that's going to be 3. Carry the 2 is 5. So we have 54 inches in total for that pipe. Now from here, I'm going to convert the 54 inches into feet and inches, and we do that by dividing by 12. Because again, to go from inches to feet, you are going from small to big, so we'll divide by 12. So let me show that right over here. 12 going into 54. Everybody, how many times does 12 go into 54? That'll be a clean number. That'll be, or not a clean number, that'll be 4, because we don't have exactly what we need. We have part of what we need. So that's going to be 4 whole feet. And let's see what remains. Let's see the remaining number of inches. So minus 48, that's going to give me 6 left over. And that'll be 6 inches left over. And there we go. 4 feet, 6 inches is that final answer. So for those of us that may have been a little confused about that right there, the calculation step, let me know if that makes a little more sense before we continue. I got you. Right on. I got you. And Saeed, yeah, taking the 3 multiplied by the 12 and then, going with the 6 multiplied by the 3 and then bringing it all back. Yep, that absolutely works. Perfect. So let's go ahead and keep the party going here. We still got plenty of time. Should be able to get at least 2 more questions in, especially with the nature of these next ones. So let's look forward here and let's get this done. All right, my party people, let's keep the party going. Here we are. The question reads, again, always begin with that question sentence. How much should you expect to pay to ship the item? Sounds good. So right there, how much should you expect to pay to ship the item? That's really all we care about. We just want to know right there that there's an item being shipped, and we just want to know the cost. So with that, let's start reading the story. You'd like to ship an item that weighs 1 pound, 1 ounce. Let me just mark that down as important information because it has to do with the premise of the problem. So the item weighs 1 pound, 1 ounce. Right there. All right, perfect. Then up next it says, the post office charges $9 for the first 12 ounces and $4.50 per ounce thereafter. So the word thereafter, let me be very clear about what that word means. Thereafter means, hey, this $4.50 per ounce, it only applies to the weight after 12 ounces. Anything 12 ounces and below, $9. If it's just 1 ounce, $9. 5 ounces, $9. 12 ounces, $9. If it's 13 ounces, that's $9 plus $4.50. If it's 14 ounces, still $9, but then it's $4.50 times the 2 extra ounces. So I want to really lay that groundwork here before we start writing things down. We have to understand that this rule is in place. Let me go ahead and just write this here on the side. Here is the rule. The rule is the first 12 ounces, so up to 12 ounces, it's going to be $9. After 12 ounces, it's going to be $4.50 times the extra, and I'm going to make sure that's very clear, times the extra ounces. Again, after the 12 ounces. After the 12 ounces. But this is our rule that we're going to be following. So when we take a look at the weight of the item, everybody, what might make this hard to understand how many extra ounces we have? The way that it's currently written. What's wrong with it in terms of being able to easily see how many extra ounces we might have? Yeah, the main problem here is that it's written in pounds and ounces, right? The main problem is that it's not just written in ounces. It's pounds and ounces. So that's where we have to convert here. We're going to take a moment here to convert. Absolutely, we got to know conversions. And with that, let's get it done here. Everybody, 1 pound is how many ounces? Yeah, that's 16 ounces, not 12. I know we've been working with feet and inches most of the day, but yeah, that's going to be 16 ounces. We still have that ounce listed there, so don't forget that. We have that extra ounce there, so that's going to be 17 total ounces. This is what we're working with. And so now that we know the number of ounces that we're actually working with, we can take this over here and I can split this into 12 ounces. And how many ounces, everybody? What's the extra? The extra here, correct, is going to be 5 extra ounces. Again, the first 12 ounces right here, this is $9. That's $9. We're good. We're done right there for that part. But then we have the extra 5 ounces. So we're going to have 5 extra ounces. And we said, my party people, that per ounce, we will multiply $4.50. So let me zoom on in here so you can see this much better. So we're going to multiply this by $4.50 per extra ounce and watch the magic. 4.50 or 4.5, either way is fine, times 5. We have 0 times 5 is 0. 5 times 5 is 25, carry the 2. 4 times 5 is 20, carry the 2 is 22. And then from there, my party people, how many decimal places are we bringing back? Yeah, 2 decimal places is what we're bringing back. 1, 2, 1, 2, and there we are. So we have $22.50 for that extra weight. But don't forget, we still have to pay the $9 for the initial 12 ounces. The way that we got this 5 here, I saw that question in the chat box, is because the 17 ounces is the 12 ounces that we pay $9 for with an extra 5. 12 plus 5, that's what makes the 17. So with that, boom, we pay an extra $22.50 for those 5 extra ounces that we have to add back to the $9 that we already pay. And if we do this on the side over here, we'll see that we have $22.50 plus the extra $9, and that's going to be $31.50. And there we go, everybody. We are all good. We're set. Answer here is A. My party people, how are we feeling? Do we feel like we had a breakthrough on this one? You know, as long-winded as this one was, we should be feeling pretty good about at least picking up and understanding the steps that we went through. Oh, so it looks like some of us made, and again, this is why we want to make these mistakes here so we don't make them on the test. So let me ask you this, everybody. Who here went ahead when they got the $22.50 and you saw that as answer choice B? You were like, huh, no more work to do. Answer's B. Yeah, that's going to happen, right? So remember that you should not let the answer choices tempt you. You have got to be sound in your reasoning. Notice how when I got the $22.50, I didn't even look at the answer choices, but even if I would have reminded myself that, hey, this is only part of the cost. I had to pay $9 initially as well. And that's how you have to remind yourself to add those back together. That's why I drew these arrows left and right to get that right at the end. Remember, everybody, make it a habit. Make it a very good habit to express your reasoning before you calculate. Because if you don't, you might get got. But either way, great job. Even if you did get $22.50, it means you got part of it correct, which is okay in my book. But we don't want to strive for okay. We want to strive for great. So just keep working at it, everybody. You're making very good progress, and it just takes a little more time. So with that, it looks like we will have time for one more problem. So let's go ahead and get it going. All right, so checking this problem out, everybody, this is one of those problems where, hey, if you have tunnel vision and you've been doing unit conversions and converting units all day long, you might get, tricked into thinking that you have to convert here. But everybody, in this case, in this problem specifically, do we have to convert in this one? Yeah, we really don't. We really don't. If you pay attention to the wording, it's going to be very clear that we actually do not need to convert. Let me go through it with you. I got your back. So, starting off, it says, how much should you expect to pay to ship the item? Okay, sounds good. Let me highlight that right there. How much should you expect to pay to ship the item? Let's understand the item and the rules for it. Let me go ahead and make my little rule set here on the right side. And here's what we see. It says that you'd like to ship an item that weighs 1 pound, 4 ounces. So the item right over here, 1 pound, 4 ounces. Okay, sounds good. So with that, up next, let me just highlight that there. Up next, it says the post office charges $7 for the first pound and $6.50 per ounce thereafter. So what that means to me, my friends, is that, hey, the first pound, let me write the rule here. The first pound equals $7. After that first pound, we're charging $6.50 per ounce. So everybody, guess what? This first pound, quote unquote, it's right there. That's the $7. So this immediately, we can move to the side and say that's $7 right there. That is exactly 1 pound. And then the 4 ounces, no worries. We can continue on by noticing that afterwards, it's $6.50 per ounce, and that's 4 ounces. So we'll take the $6.50. Let me just do this here on the side. Let me zoom on in a little bit. So we're going to do $6.50 multiplied by 4. And with that, we have 0 times 4. 5 times 4 is 20. And then 6 times 4 is 24. Carrying the 2 is 26. And so we'll bring back 2 decimal places. 1, 2, 1, 2. And that's going to be $26 for the extra 4 ounces. But if you were to do this a little quickly, guess what's sitting there? Guess what's sitting there trying to trick you? We're not done though, because we need to take the $7 and the $26. We will bring that together. 26 plus $7. That's going to give us $33. That's the total that we'll pay. And there we are. So with that, who here didn't make the same mistake twice? Who here learned from that mistake from the previous question? Good. So, I had to give you an opportunity to redo that, and get that right. Now, with that said, everybody, remember that this is not the end of unit conversions. We've been working heavily with feet and inches. We threw in yards in there. We threw in some seconds and minutes and hours, sure. But we have other conversions that we can work with. So that's why after this lesson, it's very important that you continue the progress in the program so you can continue practicing, watching lessons, doing worksheets, and getting everything you need to put yourself in the best position to pass.